podcast. This is our last lesson before our review on Thursday for lesson 23. And Lauren's with me to get started because she has to go to work. Okay.
Is this?
So I was just plugging in all this. Is recording. So I just started
is this Thursday the last time we meet?
No, and just so when they look at it and they open it up. So I'm not really talking to you. I'm talking to whoever is going to ever watch this. So they'll know what we're doing. So it's 8:05. Let's get started.
Oh.
Let me just make sure. Sorry, I have girls' camp going on tomorrow, and they are texting like a zillion things. I'm just trying to make sure that.
Gross.
It's not us. Okay, so we'll start on the group quiz before you have to go.
Okay.
Hi.
Hi. Here you guys.
Okay, so we're going to hurry and get started because Lauren has to go into work.
Okay, sounds good.
So I just went ahead and I put in my, let me share the screen over here. And just put in this information so that you can see it. This is the chart we're going to be using. So if we go back up, we start with number 3. So this is the true linear regression is y equals, I don't know what is that, what, bot 0 and beta, oh, beta, that's what it is, beta naught and beta 1 times x, where both beta naught and beta 1 are unknown. What is the null and the alternative hypothesis? So we know the hypothesis is equal. I think it's the third one.
Beta 1 equals 0 and beta 1 doesn't. Okay.
Well, yeah, actually. That's the one I think it is, because they're all beta 1, so that has to be. Okay. That's just my thought. But if you have other information, I'm happy. So number 4.
Is it the third one as well?
Number 4?
Yeah.
I put the third, yeah. So
okay.
The difference is between the y value and the predicted.
Okay.
And
yeah,
then
that's what I got.
Okay, number 5, a plot of residual supports using linear regression when
the residuals look normally distributed.
Yeah, so that's what I put, because it's supposed to make a line, although I could never make the QQ plot work. I just don't know what I was doing wrong, but I couldn't get it to work. For the next 8 problems, use the data found on math self-sufficiency. Use the constant intervals as explanatory variables, so I did that, and I put in the y. It says, compute the residuals for the data software. What statement best describes the residuals? Okay, so this was the part that I was kind of a little bit unsure of. Let me see if I can scroll this thing over a little bit. This is the part that I was kind of like, I couldn't really tell because I was trying to follow along and make my Excel do it, and I just wasn't sure, like, so this isn't my residual, right? And
the residuals
need to make a line.
Yeah, let's see.
So do we need to take these residuals right here and plug them into that QQ? Okay, residuals form a linear line. It's not negative, right? Because it's pointing up.
And
the residuals are not all negative. So I could try this, and maybe you guys can help me figure it out. So if we take their residuals right here, oops, okay, and we copy them, and I go and get that QQ plot. So, and I put it in right here, and I paste the numbers, values into there. Oh shoot, that needs to go into the QQ plots. And paste the values in. Okay, so I don't think we have.
Would it be the
Yeah.
first one then?
Be the first one.
Yeah, because it's not negative. The residuals do not form a linear pattern.
Yeah, it has to be that. I think you're right.
Okay.
All right, number 7. Based on the QQ plot for these residuals, what can you say about the residuals? Residuals are clearly not normal. Residuals are fairly normal. The residuals look right skewed.
Are clearly not normal, right?
I think
Clearly,
clearly not
something like
normal.
that.
Clearly it's a mess.
Yeah.
Okay, number 8. Use software to create a scatter plot of the data. Ding, it's right there. Let's shift this over a little bit. Okay. There is a linear relationship between X and Y. Okay, with use software, scatter plot of the data, given the scatter plot, residual plot, and the QQ plot. Which of the 5 assumptions about linear regression are satisfied by this data? So what's the difference between the scatter plot, the residual plot, and the QQ plot?
Use the software.
So this is scatter, isn't it? When it's,
That's a scatter plot, I think.
and then when we put it on the QQ, isn't that, I don't know what the residuals plot is. Which of the 5 assumptions about linear regression? I think I have it written down somewhere. Okay, so linear regression. Number 1, nope, that's not it. Say it when we have sufficient evidence to say this. Okay, number 1, there is a linear relationship between X and Y if there's a hot dog shape. Does it look like, oh, you know, we're gonna put that line thing on. That's what that is.
Min just texted. She said link question.
Hmm. Okay, let me try it again. Add her, let's try one more time. And send it to her Gmail. Okay, that's the one she gave me before. Okay, I sent it again. Okay. Is she in? Okay, do you remember how to do that regression line thing? Where we're supposed to make that line that runs through the middle? I think that's the regression.
Software to create a scatter.
That's the only thing I can't remember how to do. There's a linear relationship between X and Y. Kind of looks like a hot dog, sort of. The variant, I'm gonna say yes, little last one. Okay, the variance of the error term is constant for all values of X. The error of the normally distributed, there's no curvatures, no megaphones, no outliers. It's crazy looking, so I guess.
Yeah.
Okay, the residuals are normally distributed. I don't know.
I don't think so.
I don't think so either. Okay, X values are measured without error. Well, we hope so. Sure. Observations are independent. Well, we hope so. Right? We can't really prove them. All right. Hey, man, what do you think about this on number 8? We'll go back. Lauren just has to get off early for work.
Okay.
Look at number 8. Do you remember how to make a line? Like what we need to do to make that line run through the middle?
I'm not sure.
Neither. I'm trying to remember how it went. I just did this yesterday and I thought I knew what I was doing. And I was like, okay, I know what I'm doing. Okay, so this is what we looked at. I don't know. I think the residuals plot and the QQ plot. What are the assumptions about the linear regression are satisfied by this data? I think I don't know how to work the software is my problem. Do you agree or disagree with these 4 that we chose? For number 8.
Are you asking me?
Yeah.
So which one did you pick again?
Well, it says you can check all that apply to number 8.
I think it's the first 3 instead of the 4.
Okay, so here's our QQ plot that we made. So I went and we took the residuals. So here's our residuals, and this is the plot that it made. So it's everywhere, but I don't know how to make it line up.
So is that not normally distributed?
I thought it was normally distributed, but I thought it also at one point had to make like a line, doesn't it? Somebody look it up. See what that is.
All right.
Somebody look it up and figure out the QQ plot and sorting that out. And we'll kind of move on and then we'll come back to it. What is B1? So Janine, you're doing that, you're looking it up.
Yeah.
What is B1? The estimate for the slope. So B1.
If the data is normally distributed, the points in the QQ normal plot lie on a straight diagonal line.
That's not normally distributed then. That's what it's saying, right?
Yeah.
Okay.
Mm.
Okay. So if we go down here, so I took this information from right here. The input 12.695. And it says information, now construct a 95% confident interval for B1. Input your answers for the lower bound and upper bound. So number 10, input your lower bound. And so we're looking right here. So that would be 10.674. And your upper bound would be 14.715. Then it says, based on the alpha's level of significance 0.05, what decision would you make regarding the hypothesis test for B1? So t-score, p-value, and it looks like it is going to be a bunch of zeros. And so we would reject, right?
Yeah.
Reject the null because the p-value is less than 8. Okay, 13. For the hypothesis test of B1, if you reject the null hypothesis, what does it mean?
If you reject the null,
I think it's the last one, but
I think it's the last one too. There is insufficient. Okay.
Yeah, I think it's the last one.
okay. Okay, using this data of the crocodiles for the next 5 problems, head was used to predict the body length. For this data, which is the dependent variable?
Body length.
Yeah. Now construct. Okay, let me plug in numbers for that. I'm going to shut this off and restart it.
Okay, I have to head out for work.
Okay.
Is there anything I should know about the thing due for this week?
So do you guys want to talk about it on Thursday? Or do you want us to email you?
We can talk about it on Thursday. It's up to you guys.
Yeah, that's fine.
What did you guys think of that? The alternative, my options of how we could calculate. Did you turn in just our basic, like what we said we would do in the beginning?
Yeah, I had added
Okay.
some of the stuff that you had put on.
Okay. I was just curious. I don't really care. I didn't know, but I just kept thinking about it, and that's what my brain came to the conclusion that I think.
I checked it yesterday. I haven't checked today, but I don't think that it was graded yet.
So we just need to probably add that on. If that's what you submitted, then we need to add it to our. We just need to know exactly what you submitted, I guess.
All right. Yeah. All right. I'll email you what I had submitted when I get home from work.
Sounds good. Have fun at work.
Yeah. All right. See you guys.
Bye.
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 Okay, sorry. Let's get over to the right one. I just have to restart it because I don't know why, but I feel like, okay, so body length is right here. And then let me grab the head. Oh, shoot, that was head length. Okay, so if we slide this little bar over, there's our scatter plot. Doesn't look very scattery. Okay, in the upper bound would be, right, where are we at on our questions? Okay. Input your answers. The margin of error for this 95% confidence interval is, okay, so this is when we take away and divide by 2. Okay, so this is what I came up with, and I don't know if it's right. So I came up with 0.443. I had subtracted this 8.1 minus this, and then took that difference and divided it by 2.
Okay.
For the,
Let me. I'll do it really quick.
Yeah, I got someone.
3 minus.
okay. If we go to the lower bound, we have 7.
I got the same thing.
And then if we go to 17, the upper bound is this 8.
8.103.
Yeah. Okay, 18. Based on your lower bound and your upper bound from the last 2 problems, what can you say about B1? You're 95% confident that the interval will contain the true value of B. The interval will contain, chance. Okay, so obviously number 1, right? And then we can save all our responses. Okay, so then we'll run back up here to the top. So starting with question number 3, so we chose the third one. We said B1 is equal to 0, and the alternative would be not equal to 0.
Okay.
And then number 4, we chose the third one, the difference between the y value and the predicted value. Number 5, the plot of residuals supports using linear regression when, and we said residuals look normally distributed based on rule number 1. No, wait, based on rule number 2, I think. I don't know. I have no idea. I have no idea. That was my guess. And then we got to number 6, and we said, compute the residuals for the data using software. What statement best describes the residuals? So we knew they weren't a linear pattern, and we knew that they're not all negative, so we process of elimination chose that one.
Sounds good.
And then 7, we said, based on the QQ plot for these residuals, what can you say about these residuals? And since they looked all scattery, we just decided that they're not, clearly not normal.
I thought they were fairly normal.
Are they? Okay, so this is the part where we're kind of not sure on. So, and you, what do you think it is?
I think it's the second one.
The second one? Okay. So here is there's our QQ plot. When we put in those residuals, that's what oh, you know what? Oh my gosh. Hello. We have to put this in order, don't we? From smallest to largest. Boom. That makes a huge difference.
Oh.
So now, I just thought that. Okay, so now we do have, okay, so residuals are fairly normal. Residuals form a linear pattern. Residuals look normally distributed. Okay. So where's that other one? Okay, the linear, okay, so they're normally distributed. The linear relationship, there is a linear relationship between X and Y. The variance of error is constant for all values of X. Doesn't, I guess, the scatter plot? I don't know. X values are measured without error. We can't tell that for sure, and observations are independent, and we can't prove it, but hopefully they are. So all of them, or do we uncheck this one? Since we don't really know what that is.
The variance of the error term is constant.
The thing I wrote down was the error term error is normally distributed. So there's no curved pattern, no megaphones, no outliers.
I don't know for this one.
Okay, highlight column D and E to create a scatter plot. Make a Q and Q of residuals only. Oh, okay, hold on. So hold on, oops. Undo whatever I just did. I don't know what that is. Okay, I don't know why. Let's go like this. I was trying to highlight it all. I put a little note on the side. And then we go up here and we do data. And I don't know, insert should be right there. But probably because I just jacked that thing up. Let me just close it out. Okay, hold on. I think I figured this out. But we can save it if we need to. I'll submit it and I'll see what we got. Let's see if we need to waste time doing that. Okay, so far, so good. But we missed number 6. And we missed number 8. And the rest look good. So number 6 and number 8.
I think number 6 is the first one, the one that we picked earlier.
That's weird. I thought we'd get 6 right. The residuals from the linear plan. Yeah, I mean, the residuals are all negative. That's
Yeah.
false. I think Min's right.
Compute the residuals for the data using the software. Which statement best describes the residuals? So you think it's the first one?
Yeah.
Yeah.
Okay. And then what about, so 6, let me write down 6. Okay, and so 8 we missed. So I think we have to go learn what those things actually are. Okay, so we probably need to just go back and review the beginning of that. Let me write these down real quick. Okay. Anybody figure out what 8 and 6 would be?
I think it's the first 3.
Because I'm thinking to take off the observations are independent.
Okay.
Let's, I'm gonna submit what Min said, the first 3 and
Okay.
see what we get. So I have everything else the same as you guys except 8, so the third, okay. Okay, Min's right. I got 100% on the thing. So for number 6, it's the residuals are between about -40 and 25, and number 8, it's the first 3.
And first 3.
Mm-hmm.
Okay. Thank you. Thank you, man.
I don't know.
All right. So on the, have you guys read over the requirements for the, whatever this thing is called? I don't know what it's called. The study design slides, power chart. Because I just glanced over it at work briefly, and what we could do, I'm going off to girls camp here in the morning, and I'm trying, my goal is to come home about 2 p.m. Thursday and kind of review all this and be ready for our group meeting and do my other homework, and then go back up there. So we can try to brainstorm and be ready on Thursday.
Yeah.
And do that and be ready on them. Okay. All right. I'm going to stop our broadcast. And you guys have anything else you want to Okay.
I'm good.
Okay. Me too.